Polygons. So some of the things that we're going to be doing with regard to polygons is that we're going to identify most of them and the number of sides that's associated with them. We're going to find the sum of the interior angle, find an individual interior angle measure, find the sum of the exterior angles, and find the measure of an individual exterior angle. So here are some polygons that you've already seen and we've already contended with. And the first one is a triangle and the second one is a quadrilateral. And we know that the triangle has 3 sides and a quadrilateral has 4 sides. Then we have a 5-sided figure called a pentagon. So you're going to have to know the terms as well as the number of sides associated with them. A hexagon has 6 sides, septagon has 7 sides. A septagon or 7-sided polygon is also known as a heptagon. Octagon is 8 sides, nonagon 9, decagon 10 sides, and a dodecagon has 12 sides, and an nthgon is something like, 26 sides. So if there's no term for it, we just take the number of sides and put a dash gon next to it. So we have some definitions, and we've already touched on this before back in the beginning of the school year, but it's come back again. So a convex polygon is a polygon with all its interior angles less than 180 degrees. As a result, all the vertices of the polygon will point outwards, away from the interior of the shape. A triangle possesses this quality. A pentagon possesses this quality. So a concave polygon is basically opposite a convex polygon. It's defined as a polygon with one or more interior angles greater than 180 degrees. It looks sort of like a vertex has been pushed in towards the inside of the polygon. So take note that a triangle could never be concave. So how would this look? Something like this. Okay, so we have the obtuse angle down at the bottom here. And we can make it actually a little bit wider, make it look more obtuse. And then we have that angle that's pointed more towards the interior. In a regular polygon, anytime you see the term regular associated with polygon, that means equal angles and equal sides. That's like the perfect polygon. We like to have equal angles and equal sides. And when we do have equal angles and equal sides, we're able to use formulas in which to solve for individual angle measures, whether they are interior or exterior. Okay, so we have convex regular polygons that we'll be dealing with, and as a result, the sum of the exterior angles is always equal to 360 degrees, and the sum of the interior angles is equal to 180 times the number of sides, n, minus 2. In order to find the measure of one exterior angle, you take what the sum is, 360, and divide by the number of sides. And in order to do that for one interior angle, you take the sum, which is 180, times the number of sides, n minus 2, and divide that by the number of sides, and you get that value. Okay, so we already dealt with quadrilaterals. In this case, we have a rectangle. And we know that in a rectangle, each angle measure is 90 degrees. But if we extend each of their line segments out, as you can see, you have another 90-degree angle, because the sum of these two angles that lie on this line next to each other, these adjacent angles, they are linear pairs, they're supplementary. And if you multiply that by 4, you'll get 180 degrees, which is one of the properties we had already stated. So we have interior angles, which are all the angles inside, and we have adjacent angles to each of the interior angles. We call them exterior angles, where their sum is always equal to 180 degrees. So inside angle is interior angle, and outside angle is exterior angle. So angles A, B, and C are called the exterior angles, and angles X, Y, and Z are interior. Okay, so if we look at the picture to the right here, we are being asked what kind of regular polygon it is. And regular means equal sides, so we have 1, 2, 3, 4, 5 sided figure. That means it's a pentagon. We know that the sum of the exterior angles of any polygon is 360 degrees. The sum of the interior angles is 180 times the number of sides minus 2. So that gives us 180 times 3, and the product is equal to 540 degrees. So the sum of every interior angle is equal to 540 degrees, and we say degrees because angle measures are in terms of degrees. The measure of an exterior angle is 360 divided by the number of sides, and that gives us 72 degrees. And the measure of one interior angle is we take the sum, we already know to be 540 degrees, divide by the number of sides, and we get 108 degrees. So each interior angle is 108 degrees. And the measure of an exterior angle at each one of these interior angles is 72 degrees. So this is what it looks like in a diagram. And you just keep putting 72 degrees next to each of these angles. I've run out of room, but you could go ahead and finish that up. So the next regular polygon we have is a 1, 2, 3, 4, 5, 6-sided figure. So that's a hexagon. The sum of the exterior angles, 360 degrees. The sum of the interior angles, 180 times 6 minus 2. So 180 times 4 gives us the quantity of 720 degrees. The measure of one exterior angle is 360 divided by 6, which gives us 60 degrees. And the measure of one interior angle, we take 720, divide that by 6, and get 120 degrees. So that means one exterior angle is 60 degrees. As you can see, this is an acute angle, and the measure of one interior angle is 120. The sum of 60 and 120 gives us 180 degrees, which makes sense because they are adjacent angles on a line, so it's a linear pair. The next regular polygon that we have is a 1, 2, 3, 4, 5, 6, 7, 8-sided figure. And I know it looks a little off, but that's the best I could do with a picture. Okay, but let's just pretend that they're all equal because we called it regular. Indeed, this is an octagon. The sum of the exterior angles, 360 as usual. The sum of the interior angles, 180 times 8 minus 2, 180 times 6. So that gives us a product of 1080. So the measure of one exterior angle is 360 divided by 8, and the measure of one interior angle is 1080 divided by 8. As a result, one exterior angle is 45 degrees, and one interior angle is 180 degrees. So now it's your turn to come up with your own example. Let's see if you can do it. We've already done a pentagon, we've already done a hexagon, and we've already done an octagon. So you pick another one and complete your own. I'm going to go with a dodecagon, a 12-sided figure. I'm not going to try to draw the picture though. So we know the sum of the exterior angles is 360. You should also have that same answer. Doesn't matter what kind of polygon you choose. The sum of the interior, however, will change. Measure of one exterior angle. Hopefully you took 360 and divided it by the number of sides that's associated with the polygon you selected. And the measure of one interior angle, all I really have to do if I want to cheat is take the 30-degree angle that I just found for the measure of one exterior angle and just subtract that from 180. And I get 150. But if we also take 1800, the sum of the interior, divide by the number of sides, we also get 150. So there you have it. So let's engage in some practice here. If the measure of an exterior angle of a regular polygon is 30 degrees, then the polygon is, okay, so they give us the measure of one exterior angle to be 30 degrees. And ironically, we already found that in the last page, so already I know it's a dodecagon. But what if we didn't do that? What if coincidentally we hadn't done that? We'd have to solve for this. So I'm going to set it up as though I didn't know what the angle measure is. So we are talking about one exterior angle. The formula is 360 divided by the number of sides, and we're going to set that equal to the angle measure. All we need to do is solve for n here. So I'm going to switch the 30 in the n. That's cross multiplication, and I'm not testing you on that. So anytime you have a variable in the denominator and you have something that looks like a proportion, just switch the n and the 30. So 360 divided by 30 is equal to n. These two cancel out, and 3 goes into 36 12 times. So this is a dodecagon. What is the number of sides of a regular polygon whose interior angles each measure 120 degrees? So I have the value of one angle measure. I'm going to write the formula out. So 180 times the number of sides minus 2 all over the number of sides. I need to solve for n. This is going to require some more work. I'm going to cross multiply and distribute 180. So I get 180n minus 360 is equal to 120n. So let's just go up here now. I see like terms. I need to get them together. So I'm going to subtract 120n from 180n. And add the 360 to the other side. This is just solving equations. I get 60n is equal to 360. Divide out the 60 and get n is equal to 6. So this is a six-sided figure, and as a result, the polygon that we are looking for is a hexagon. So this concludes our lesson on polygons, and it's your responsibility to complete the associated assignment during class.